Hi everyone, and welcome to the security track of the ASEAN Summit 2022. My name is Matt, and I am part of the FSI security and compliance team from Amazon Web Services. We know that many of you are concerned with security in the cloud. Uploading sensitive data into a third-party cloud operating outside of your premise is a new concept for many and presents a new range of security challenge when compared to on-prem deployments. This is further compounded if you're a regulated entity and have to demonstrate assurance that your data is adequately protected within the cloud. In this session today, we will deep dive into how the use of data encryption and key management can provide a preventative control for managing data confidentiality and information security. This presentation is not designed to explain how encryption works, but to look at how it can be practically applied to address risk and compliance requirements. We'll start off with some basic terms related to data encryption so that we're all on the same page going forward with terminology. Following that, we'll look deep into some of the key security risks that customers face when placing their data into a cloud environment. From there, we will then explore control options and solutions related to key management and also expand on the shared responsibility model to describe who covers what when considering data encryption. And finally, we will look at the practical application of key management through a use case. Whether you're getting started with the cloud or already have workloads in the cloud, key management provides a simple yet powerful control for demonstrating the confidentiality and security of your data. We're going to start with some basic definitions and concepts relating to encryption, just to ensure that we're all on the same page with regards to terminology. This is not a technical talk, and we will only be skimming over this section. When building on AWS, security and compliance is a shared responsibility between AWS and yourselves, the customer. AWS is responsible for security of the cloud. This means that AWS is responsible for protecting the infrastructure, among other things, that runs all the services offered within the cloud. Data key. This is the mechanism that is used to encrypt the data itself. The easiest way to think of this concept is that of locking your data in a safe. Once the data is locked in the safe, the only way to open it is with the key. So the person who controls the key controls access to the contents of your safe. Therefore, if you want to protect your valuables, locking them in a safe is only part of it. You also need to ensure that you protect the key to ensure that an attacker or an unauthorized person can't access what's in the safe. To keep things simple, we won't go into symmetrical or asymmetrical keys. Encryption algorithm. This is the mechanism by which the data is encrypted. Think of the algorithm as the lock on the safe, and the key is the object that opens the lock. As with locks, there are a wide range of encryption algorithms, each with their own varying pros and cons. Ciphertext. Remember plaintext data is unencrypted data? Well, ciphertext is the opposite of this, and this is the output of encrypting your data. In this form, data is unreadable to anyone and confidentiality can be assured. The only way for an attacker to access this data is if they can access the key used to encrypt the data. Without this, ciphertext is useless. As we can see from discussing these terms, whether you are protecting your encrypted data or valuables in a safe, ensuring control over the key is vital to the security of your assets. Now let's look at some of the specific information security challenges relating to the cloud. For many of you, you will be familiar with these challenges. We are setting the scene here to highlight some of the key challenges that key management can address and to answer fundamental information security and compliance requirements for you. Who has access to my data? When uploading data to the cloud, or any third-party custodian for that matter, a fundamental security question is, how do you manage access to the data and ensure confidentiality when the data is not residing within your premise? Can the CSP access my data? Data uploaded to the cloud resides within the premise and hardware of the cloud service provider. With this model can come the question of, can the CSP access my data in any way? Whilst AWS is unable to access customer data, anyone who has been audited will know that you need to demonstrate what preventative controls you have in place to address this risk. How can I maintain control over encryption keys? As we have covered earlier, key protection is vital to ensuring the effectiveness of encryption as a control. Given their importance, ensuring that you have complete control over your keys is fundamental to demonstrating control and security of encrypted data. What if the CSP is forced to hand over my data? We will not disclose customer content in response to request unless required to do so to comply with a legally valid and binding order, such as a subpoena or a court order. Additionally, when possible, we would notify the customer before disclosing their content so that they could seek protection from disclosure. It's also important to point out that customers can choose to encrypt their content as part of a standard security process for highly sensitive content. AWS provides tools customers can use to encrypt their data at rest or in motion, and customers can choose from a number of supported third-party security solutions. Content that has been encrypted is rendered useless without the applicable decryption keys. How can I seek assurance of controls in place? It's one thing to discuss controls available and tell people that something is in place, but it's another to provide them with assurance that these controls are in place and operating as designed effectively. To address this, AWS has a wide range of independent reports available for the security of the cloud. What are the key benefits from a compliance and security perspective of encryption key management as a control? A request to disclose customer content is not automatically an obligation for AWS to decrypt. Cloud content that has been encrypted is rendered useless without the applicable decryption keys. If the customer has used AWS KMS to store keys, no one, including AWS employees, can retrieve customer plaintext keys from the service. Further, keys created by AWS KMS are never transmitted outside of the AWS region in which they are created and can only be used in the region which they were created. Essentially, in order for AWS to disclose the keys to the requesting authority, AWS would need to build or alter its technology for this purpose. AWS has made it clear in public filings in US courts that it does not believe that US law can compel providers like AWS to build or alter its technology to facilitate a law enforcement request. Further, in the context of Cloud Act, it expressly prohibits executive agreements from creating any obligation that cloud service providers be capable of decrypting content. AWS KMS is designed so that no one, including AWS employees, can retrieve customers' plaintext CMKs from the service. The service uses hardware security modules that have been validated under FIPS 142 to protect the confidentiality and integrity of customer keys, regardless of whether the customers use AWS KMS or AWS Cloud HSM to create their keys, or they import them into the service themselves. Customers' plaintext keys never leave the HSMs, are never written to disk, and are only ever used in the volatile memory of the HSMs for the time needed to perform the customer's requested cryptographic operation. Updates to software on the service's host and to the AWS KMS HSM firmware is controlled by multi-party access control that is audited and reviewed by an independent group within Amazon, as well as a NIST-certified lab in compliance with FIPS 142. Also, the AWS KMS is designed so that the use of keys is protected by access control policies that the customer defines and manages. There is no mechanism to export plaintext keys. The confidentiality of the encryption keys is crucial. Multiple Amazon employees with role-specific access to quorum-based access controls are required to perform administrative actions on the keys themselves. Secondly, KMS records the use and management of cryptographic keys in AWS CloudTrail logs. The customer can use AWS CloudTrail logs to inspect its use of cryptographic keys, including the use of keys by AWS services on behalf of the customer. We will now expand the shared responsibility model to delve into some of the operational requirements that key management within the cloud presents on the customer side of the shared responsibility model. From a cloud compliance and assurance lens, the evidencing of these requirements will also sit with the customer. With the use of data encryption, the decision to encrypt resides with the customer. This is important to understand in the context of responsibilities. AWS provides controls for customer to encrypt data, but the decision and the activities related to this sit with the customer. When it comes to questions like, is my data encrypted in the cloud? The first question to ask is, did I encrypt my data or not? This reflects the nature of the shared responsibility model, and also how a CSP will provide evidence to demonstrate encryption mechanisms. The CSP can show what options and solutions are in place, and that they are operating as designed, but whether the user has made the decision to encrypt or not resides entirely with them. The responsibilities that sit with AWS are to generate keys in HSMs and protect within the service. As with symmetric keys, nobody, including AWS employees, can access plaintext private key material. All access and operations are recorded, availability and durability still applies, and AWS KMS will continue to scale to meet your ongoing needs. The responsibilities that sit with the customer are: use keys designed for signing and encryption accordingly. You must not use asymmetric keys in an integrated AWS service that lets you include a KMS key ID, getting certificates for public keys, and setting the right policies. Gaining assurance over solutions on the AWS side of the shared responsibility model can be obtained by AWS's audit programs. KMS is in scope for all AWS audit programs, including ISO 27001, PCI DSS, and SOC 1, 2, and 3 reports. KMS is also in scope of the FedRAMP high controls, and this applies for classified USA information. For KMS testing, specific KMS controls are tested within AWS's SOC 1 report, and we have NIST assessments for our KMSs evaluated at FIPS 142 Level 2 by NIST, and for our Cloud HSMs evaluated at FIPS 142 Level 3 by NIST. We have covered a number of core concepts to key management, so let's now look at a working example of how this can be applied. The first step for the user is to generate an encryption key. Once this has been created, then they're able to start encrypting data. As mentioned, the user must be able to also ensure the security of their keys, otherwise the encryption solution is useless. With the key separated from the encrypted data itself, users can implement identity and access control over their keys. Now this presents two benefits. The first is to ensure that the key can only be accessed by authorized users. No key, no access. The second is to provide a list of authorized users who can access the key and therefore the data, and can be leveraged to create a logging and monitoring detective control, in that anyone who is not on the approved list that tries to access the keys or data can be flagged for further investigation. This is also really useful during audits, as you can provide assurance that via the IAM control, only the users on the list can view the encrypted data, as without the key, the data in the ciphertext itself is useless. Even if an attacker can access the ciphertext, it cannot be read or decrypted without the corresponding key. This provides an answer to the question of who can see my data in the cloud. If it's encrypted, then the answer is, well, whoever has access to the key. Now we can see how powerful key management is as a control for information security. This control can effectively address a wide range of information security concerns relating to the cloud. Now we're going to dive into some of the AWS key services that are available to you. AWS Key Management Service provides you with a centralized control over the lifecycle and permissions of your keys. You can create new keys whenever you wish. You can control who can manage keys separately from who can use them. As an alternative to using keys generated by AWS KMS, you can import keys from your own key management infrastructure, or you'll use keys stored within AWS Cloud HSM cluster. AWS KMS is designed so that no one, including AWS employees, can retrieve your plaintext keys from the service. This service uses hardware security models that have been validated under FIPS 142 or are in the process of being validated to protect the confidentiality and integrity of your keys. AWS Certificate Manager is a service that lets you easily provision, manage, and deploy public and private secure sockets layer, transport layer security certificates for use with your AWS services and your internal connected resources. SSL TLS certificates are used to secure network communications and establish the identity of websites over the internet, as well as resources on private networks. AWS Certificate Manager removes the time-consuming manual process of purchasing, uploading, and renewing your certificates. AWS Secrets Manager helps you meet your security and compliance requirements by enabling you to rotate secrets safely without the need for code deployments. For example, Secrets Manager offers built-in integration for Amazon RDS, Amazon Redshift, and Amazon Document DB, and rotates these database credentials on your behalf automatically. AWS Cloud HSM is a cloud-based hardware security module that enables you to easily generate and use your own encryption keys on the AWS cloud. With Cloud HSM, you can manage your own encryption keys. Cloud HSM is standards compliant and enables you to export all of your keys to most commercially available HSMs subject to your own configurations. It is a fully managed service that automates time-consuming administrative tasks for you, such as hardware provisioning, software patching, high availability, and backups. Cloud HSM also enables you to scale quickly by adding and removing HSM capacity on demand with no upfront costs. The Nitro system, the underlying platform for all modern Amazon EC2 instances, is a great example of how we have innovated and invented on behalf of our customers to provide additional confidentiality and privacy for their most sensitive data and applications. There are 3 types of protection provided by the Nitro system: protection from AWS operators, protection from AWS system software, and protection from a customer's own operators and software. The Nitro system's unique approach to virtualization and isolation enables our customers to secure and isolate sensitive data processing from AWS operators and software at all times, and optionally, via Nitro enclaves, even from a customer's own software and operators. Data residing in a Nitro enclave cannot be accessed by AWS staff by design, and also enables the use of independent encryption keys. This is a great example of how AWS services can be leveraged along with key management to deliver a controls suite with controls operating with a defense-in-depth methodology. We have covered a lot of ground today, and I would like to end with a quick summary of the key points covered today. Key management is a fundamental control for data confidentiality within the cloud. Restricting access to keys can provide assurance over who can access data within the cloud, and customers have a wide range of options and responsibility for key management within the cloud. We encourage you to get engaged with our training and certification content today. Skill Builder is our online learning center that makes it easier for anyone, from beginners to experienced professionals, to build AWS cloud skills. We offer 500+ free digital courses that can help you and your team build new cloud skills and learn about the latest services when and where it's convenient in up to 16 languages. Within Skill Builder, take advantage of flexible learning plans, which offer suggested digital courses aligned to a specific domain or job role. As you build your skills, consider preparing for one of our 11 AWS certifications. These are industry-recognized certifications spanning foundational, professional, and specialty levels to validate AWS knowledge and skills, building your credibility and confidence. We also invite you to join the AWS Certified community, which brings together AWS certified practitioners and builders in an exclusive online community. Here you'll participate in discussion forums, learning and network opportunities, and challenges from the AWS team to earn rewards and recognition. Scan one or both of the QR codes on screen to get started with your cloud skills training and certification. Thank you for taking the time today to join me. Now that you've learned how to get started, stay tuned to find out other ways to continue your cloud security journey with the other speakers today. Before you leave, I'd appreciate if you could fill out the session survey so that we can improve this session. Thank you.